This is Computer Science 305, Programming Languages. This is ML2, and that was me opening a soda. And this is the last part, which we're talking about a sorting example. So I'm sure that since we all took 132, and possibly 232 prior to even coming to this class, we should all have a good handle on sorting. It's our favorite friend from the Algorithms and Data Structures course. If you took the course from me, you should have a really good handle on sorting, like it's old hat. Anyway, so I'll open up the standard ML of New Jersey, and we're going to talk about merge sort, right? So we define the have function, which I'll have to execute here, so I'll just redefine it. Okay, so the have function is redefined. And sorry, the function divides the list into two nearly equal parts, which is necessary in order to do the merge sort, right? So this is the first step in a merge sort, obviously, because we break. If we all recall merge sort, right? You break down the list into till we get down to about one item left in the list, or nil, right? It's an empty list, and then what we do is we sort the items, and we merge it back together. Okay, so this is the example of merge sort, right? So if we want to merge, right, so we say function merge nil and y's equals y's, right? So if we have one of our tuples is nil, then it's just whatever ys is, right? That's the base case. The second base case is when we have just x's and nil, so then we say then it's just x's. On the other hand, the actual case that we care about, the general case, the recursive case, is when we have a list in both positions. So we have a list in the x position, a list in the y position, right? So if that's the case, then we can say if x is less than y, right? So if we're looking at the heads of these lists, right? This is how merge sort works, where we already assume that the list itself that we're looking at is already sorted, and so if it is merged, we're following merge sort, if we get all the way down to where we have one item in the list, that we know that item is already sorted because it's the only item in the list. So then we can merge it, right? If we ever have more than one item, so then we don't have to merge, we just return. Any other time we have to actually merge, and so that's what this whole process right here is doing. So we're checking if x, the head of the x's is less than the head of the y's, then we want to call x cons the merge of xs, y, ys, right? So this will either drive us towards, it effectively will drive us towards one list having one side being nil or the other side being nil. On the other hand, we know that if x is not less than y, then y is the one that we want to be the head of the list. So then we can say else y merge x, the x's list, right, and then the tail of y. And if we did this, we should be able to see a merge sort, right? Oh, I forgot then. Damn it! Now I have to rewrite this. So fun merge nil y's equals y's, merge, oh, that's a pipe, merge nil x's, nil equals x's, merge x's, y's equals, if x is less than y, then x cons merge xs y ys else y cons merge full list of x y. Alright, there we go. Okay, very good. So now it should be noted, as it says here, the default type for the less than is int, right, which is going to be detrimental to what we're trying to do by limiting us down. That's why we got int list here, because of the less than sign was how it was able to resolve ints. So this will work. So let's say we have just some rando list where we say merge, and actually maybe we will walk through this, right. We'll see that we have merge 2 1 3, right. So this, bear in mind that this is the second half of the whole thing, right. This is the merging part, not the having part. So we don't have merge sort all the way done. We only have two parts that will make merge sort actually work, right. So it gives us 1 2 3, right. So it takes the two pieces and puts them back together in sorted form. Same if we do merge 1 3 3 4 7 8 and 2 3 5 6, so 5 6 and 10. You know, we can verify it works as well. So it does it, the merging part. So we've seen the having part where we break the list down into small pieces. Now we actually need to see and we saw the merging part. Now we actually have to put this all together into a merge sort itself. So merge sort, right, define this as merge sort. If we give it a nil list, it returns nil, as expected, right? That's that's one base case. The second base case is if we have a simple list of one item, and it just returns that one item. Now, on the other hand, if we're going to merge sort the list, right, then if this is anything that's not one of those previous two, then what we're going to have to say is we're going to say let, and we have a val defined with pattern xy, and that's going to be called by calling have the list, right? So this is where we're going to break it down, and then we're going to use that in the expression where we're going to merge it back together. So merge, and we're calling merge sort on x, merge sort on y, right? So we're going to keep breaking this down until we get to the point to where we can actually merge it back together, and then we'll end. Right. So now, if we the type we know is int list, returning an int list, because we already know the type found for merge, right? Which we talked about was due to the fact that the less than symbol, right? Right here indicates that it has to be an integer as default. We can actually force it to be real, but we'll talk about that in a bit. So so this is giving us the merge sort for a list, right? So if we go ahead and operate this, and what we'll see is if we run merge sort on the list 4 3 2 1, right? So it's a reversed list, which would be essentially one of the worst cases. It comes back with 1 2 3 4 as expected, right? Merge sort on 4 2 3 1 5 3 6. There's a K. Oh. Say 1 5 3 6, and that gives us 1 2 3 3 4 5 6 as expected. Now we can also do nested function definitions, right? We can define local functions just like local variables using a let. Alright, so you should do this for helper functions you don't think would be useful by themselves. For example, in this case, have and merge, right? We can actually hide those from the rest of the program this way. The other potential advantage is inner functions can refer to variables from the outer one, right? So they're essentially a closure on the outer, right? They see everything that was within the same scope in which they were defined. So if we were to rewrite this, right, And so essentially, oh, by the way, you know, anything in parentheses with a star is a comment. So sort a list of integers, which I might actually, we can actually go ahead and define this as an actual function in an SML program. So pwd, we'll make a directory. And we'll open up that directory in Atom. Yes, thank you, spell checker. So create a new file, and we'll call this merge sort dot, I believe it's SML. So we call this sort a list of integers, right? And we say function merge sort nil equals nil, pipe merge sort e equals e, right? And then merge sort, hello, merge sort, and then the list equals let, from the given list make a pair of lists, x, y, where half the elements of the, that was not cool. Half of the original are in. What is going on here? Half the original are in X and half are in Y. Alright, good times. So now that we've done that, we can create the function have as before, right? And then the function have again, A cons B cons C, and say let val x y equal have cs in a cons x, cons x, b cons y, and then we call end, right? And then it's going to be continued, right? Because we're still defining the next method, right? Which is the merge. So we define this, right? Merge two sorted lists of integers into a single sorted list, right? Okay. So we say function merge nil y's equals y's, or merge x's nil equals x's, or merge, and then we have x cons xs and y cons y's equals if x is less than y, then x cons merge xs y y's, else y cons merge x's and y's, right? Okay. And then we create the set. So now we define these things, right? And now we're going to define the other definition, which is val, right? X, y equals have the list. Okay? And we're going to use all this in, in merge sort x merge sort y. Alright, so now we can then run this, and we call merge sort on, let's say, 1, 2, 3. Sorry, it was 4, 3, 2, 1. Right. Oh yeah. Well, and then we'll run on a few things. I'll run this in a bit here, so we can actually see what's going on. So we should note that, as I said before, that anything falling in the scope of a parentheses with stars is a comment, right? As we can see up there and in those two. We can also define that and we also should know that we should always comment every program, as well as every function, as well as any parameters it expects, etc. So anyway, just give me 1 second here, and then we should be good to go. I will save that. Okay, so we're back, and going ahead, and we're going to run this really quick. So we define this program, and then we're going to have it run, and we'll actually run merge sort, and then we'll just do we'll actually go run the last example from before, which was 1, 2, 3. Oh, sorry, it was 4, 2, 3, 1, 5, 3, 6. Okay, very good. Right, we'll run that, and so what we'll save that, and we'll run it from the console down in our Atom, right? And so Alice, make sure it's there. So we say SML merge sort .sml run, and lo and behold, it defines everything for us, right? We already defined all merge sorts, so it handled that for us without us having to type it in, and then we ran that at the console. Now we can do a whole bunch of things. You can actually compile these programs with SML. I believe there's an SML compiler. I don't remember what the command is off the top of my head right this instant, but we will eventually talk about that in a later lecture on ML. Anyway, you guys have a great day. Running through some of these examples. This is basically all the examples from inside the book. If we and then just kind of learn these patterns, and then as part of the exercises for this, go ahead and try both from the command line using SML or PolyML if you're on Windows, and then also by defining code in a file and then running it from there. Okay, have a great day.